Kia ora team, this is Mr. Dharma. I just wanted to update you on all of the identities that we've covered so far and then talk to you about doing some proofs. So really quickly, we started off the talk with looking at the reciprocal trig functions. These ones really unpacked what more we could find in here. So after the reciprocal trig functions, we looked at the compound angle identities, realizing that there's a difference between plus minus and minus plus and how important that is. Then we looked before that we looked at the Pythagorean identities that are derived from Pythagoras. And then today we use the compound angles to help us find the double angle identities. And we also wrote down the product to sums and the sums to products. In class, we used theta and phi. Here they've used C and D. That's okay, you choose what you want to use, okay? So, these are our identities. From these identities, what we can do is we can, in fact, do these things called proofs. So, I'm going to give you a proof now, and then we're going to do a lot more of this in class. So, here we are. The question might be, prove that sine 2a over 1 plus cos 2a is equal to tan a. Okay. Trig proofs are very standard in mathematics, and so we've got to be very careful how we do this. How we do this is we start with one side. I'm going to start with the left-hand side, LHS, and I'm going to manipulate it until it looks like the right-hand side. Okay? So here we go. I take the left-hand side. I notice that sine 2a, using my identities from before, is a double angle, so I can rewrite that as 2 sine a cosine a. And for the fun of it, what I'm going to do is I'm going to write the denominator as 1 plus, and cos 2a is also 2 cosine squared a minus 1. Okay? So watch what happens now. There's a plus 1 and a minus 1. They cancel. And so what I'm left with is 2 sine a cosine a over 2 cosine squared a. Now notice that the 2 and the 2 cancel. And if I cross out one of the cosines with the cosine on the top, I'm actually left with sine a over cosine a, which is tan a. And so since we had the left-hand side equaling the right-hand side, we have finished our proof. And what we do is we draw a little box to indicate we have proved it. Okay, this is how trig proofs work. We use the identities above to prove the statement given to us. And so the advice is always start with the uglier looking side, because it's typically easier to manipulate something uglier looking. Okay, let's do another example just to show you other ways we could do this, right? We don't always have to use these same kind of identities, but they pop up quite often. So have a look. So here we go. Prove sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. I know we've not looked at cubed thetas before, but I think we can make it work. So I am going to start with the left-hand side, because that's how I typically go, right? And I'm going to rewrite that as, because I don't have an identity for 3, I'm going to rewrite that as sine theta plus 2 theta. Right? You can split that up, that's fine. And now I can use the compound angle identity. So that will give me sine theta cosine 2 theta plus cosine theta sine 2 theta. And what I'm going to do is I'm going to make these substitutions of these double angle identities. And what's really important is notice that there's a lot of sines happening, and so I might want to do something that has a lot of sines in it. Okay? But it's okay, we can work that out as it happens, right? But let's see how this pans out. So what have I got? I've got sine theta, and I'm going to write this as 1 minus 2 sine squared theta. You know, that is from this identity right here. Okay? And then here, I've got cos theta, and then I'm going to write this as 2 sine theta cosine theta. Remember, that is from this identity here. Now, I'm going to look at it. Now I've got sine theta times 1 minus 2 sine squared theta plus 2 sine theta times cosine squared theta. Do we have another way of writing cosine? Yes, we do. So I'm just going to leave this part like this for now. We'll deal with it shortly. I don't want any cosines because look at the top, there are no cosines. And so what I'm going to do is I'm going to write this as 1 minus sine squared from the Pythagorean identity that we had. Okay? So if we do that, look at what happens. Let's expand this carefully. Sine theta times 1 is sine theta. Sine theta times 2 sine squared theta is 2 sine cubed theta plus 2 sine theta times 1 is 2 sine theta, and 2 sine theta times sine squared theta is negative 2 sine cubed theta. If we simplify, we've got sine theta plus 2 sine theta, so that's 3 sine theta. And then we've got minus 2 sine cubed theta minus another 2 sine cubed theta. So that's minus 4 sine cubed theta, which is the right-hand side. So I'll write RHS box to indicate that we have completed the proof. Okay? That is how trig proofs are done. What you do is you start with one side and you manipulate it until it looks like your other side. You get really, really good at this as you practice more. What I'd like you to do is I'd like you to practice this over the next couple of days. Thank you.